All right, and welcome. Hey, we're going to do vectors. It's going to not be easy. We're going to pay attention. We're going to focus. And I'm going to try and break this down as easy as possible. I've given this a lot of thought. And the reason why is because vectors is something that's always been a problem for me completely understanding. I just, like, a light bulb went off for me, and I now completely understand it, mostly. And I think I'll be able to teach this the best possible way. So let's get ready to hang on for dear life. Here we go. Okay, you're going to know how to use vectors to model situations involving magnitude and direction, right? Because remember, a vector, it's a quantity that has both magnitude and direction. We talked about that last time, okay? It has an initial point. We also call that a tail, and a terminal point, which we also call the head, okay? So first question is we need to identify what a vector is. Okay, again, it has magnitude and direction. So if I sit down here and I take a look at this first one, it wants me to know, does this hockey puck shot at a northwest at 60 miles per hour is a vector or a scalar? A vector has both magnitude and direction. A scalar just has magnitude. So again, does this have magnitude and direction? You bet it does. It has magnitude because it talks about 60 miles per hour. It has direction because it talks about northwest. So this is a vector. What about the next one? That's a great question. So I asked this time. This tennis ball is served at 110 miles per hour. Is this a vector or a scalar? Answer it in your head. If you said scalar, you are correct. If you said vector, you're wrong because I don't know which direction I shot it. Again, vector, magnitude and direction. 110 miles per hour. That's my magnitude. Which way did I hit it? I don't know. I could have hit it towards the judge because I wasn't happy at him. I could have hit it down the line. I don't know. It doesn't tell me. So it is not a vector. But what about the next one? Is the sprinter, oops. So the previous one was a scalar, so write down scalar. So here we go. State whether or not the sprinter is running 110 meters north is a vector or a scalar. Do you got the answer? Okay. So does it have magnitude and direction? Yes, it does. It does have both. It has a magnitude of 100 meters. It has direction of north. So I'm able to draw this like that. It is a vector. Sweet. And I would label this 100, and I might call it, A. Don't forget the little arrow. All right. So magnitude and direction. That's great. So now comes the world of, now we know what a vector is and versus a scalar. Let's take a look at how this can be done to represent things in the real life. Now this one says here use a ruler and protractor. I deleted that for you. I don't want you to use a ruler and protractor. We're just going to draw this. Okay. For V, for 10 newtons of force at 30 degrees to the horizontal. Okay. So 30 degrees to the horizontal. So what I do to draw this, again, I have 30 degrees. So I draw my horizontal. There's my horizontal. I want to draw 30 degrees. So we're talking about like that much. I label my degree measure. There's 30 degrees. This is my vector, so it's going to have an arrow on it. It's called V. And I know it's 10 newtons, so I can label that as well, 10 newtons. And that's my vector. Not too difficult. But what I wanted to point out to you, and this is the part that I do going to take a moment and I'm going to spend some time on that most people don't. We talked about adding things, right? And what I can tell you is when I take a look at this vector of 30 degrees, I drew it as a vector. But can I draw this as a resultant? Can I make up two vectors that make it to where I add it together? And the easiest way to do that or see that is if I were to have a vector here and a vector here. if I took this vector and I called it, I'm going to call this Vx. Why Vx? Because it's the x component of my vector V. And this here is Vy. It is my y component of vector V. And look, when I do Vx plus Vy, right, here's my head, there's my tail, I line that all up, that all equals V. Why is this important? I'm going to let you know shortly. But I want you to also know, how do I find out what Vx and Vy is? Vx is equal to the magnitude of V, which I denote as that. So what's the magnitude of V? The magnitude of V in this case is 10 newtons. And I probably need to know about this 30-degree measure. It's cosine of 30 degrees. And how do I find out what Vy is? Vy is the magnitude of V times sine of 30 degrees. Now again, that's not absolute value. That means magnitude in our vector world. And our magnitude here was 10 newtons. And I would use my calculator, of course. This is a calculator test, a calculator question, okay? But why does this help us? It makes it incredibly easy to add vectors later. So let's do this next one, okay? And we're going to break it into the component parts, and we'll see how it works from there. It says, yeah, blah, 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 ruler and protractor. We don't worry about this here. To diagram Z, a vector Z, for 25 meters per second at a bearing of 70 degrees west of south. That's how I say this one, 70 degrees west of south. Include a scale on the diagram. Okay, again, we don't need a scale, but here I am going to draw my angle. So here's this is north, there's south. I want 70 degrees west, here's west. So here's my 70 degrees. Oops, that's not even close. Here's south. 70 degrees west of south. So you're at south, I go 70 degrees. That whole thing is 70 degrees. And there's my vector right there. I started there. There's my head. It's 25 meters per second. I'm just going to label it Z because I'm short on room. But what I am going to say is my magnitude of Z is equal to 25 meters per second. Okay. So how do I use I want to break this in component form. I want components. Can you see the components? Here's one component. Second component. Again, I call this Zx, and I call that Zy. I go find Zx is equal to the magnitude of Z times cosine of what degree measure? And this is where you have to remember your unit circle part. Okay, all my degrees on my unit circle start here on the x-axis. So what do? I start here on the x-axis, and I travel 180 degrees, and then how much is left here? Oh, 20 degrees. So 180 plus 20 is 200. So this whole degree measure is 200 degrees. Okay, it's 200 degrees. And I do the same thing for Zy. Is Z sine of 200 degrees. Again, you would type that in your calculator, you get your actual answers. I'm not going to worry about it now. I want you to know the process. Okay? You guys can push buttons. I have faith in that. Okay? The key, here's your key. Okay? When breaking into components, okay, angle is from x-axis. Let's see another one. It says here again, ruler projector, T, again, vector T is going to be 10 miles per hour at a bearing of 025 degrees. Again, bearing, what does bearing mean? And here's my dot, there's my starting point. Okay, here's true north, there's my north direction. A bearing of 025 degrees means that this part is 25 degrees. Here's that. There's my ray, or my vector. I'm going to label it T. Again, I'm going to label my magnitude of T is going to be 10 miles per hour. And now I want to break it into component form. Again, what are my components? I have one right here. I'm going to call that Tx. I have up here, I call this Ty. Alright, so when I do this, I'm going to say, well, hey, Tx is equal to, say it with me, 10, because it's magnitude of T. I'm just going to write it right here. Magnitude of T times cosine of, what's my degree measure? Again, this is where you have to, I want it from the x-axis. I want it from here. So what's 90 minus 25? Oh, that's 65 degrees. And Ty is going to be T sine the 65 degrees. Now you might be asking yourself, hey, why is it cosine for x and y for sine? Excellent question. The reason it is cosine for x and sine for y is the whole unit circle. Remember, cosine was the x's and sine was the y's. All right? So let's see what's next. Let's see if we get anything more difficult for us. Okay, so here's our adding methods I want you to review. All right, so we had our triangle method. We've seen that before. Add two things. We had a parallelogram method, okay, where we go ahead and do the parallelogram. That's going to be a little bit different, okay. I might show you that one there a little bit later, okay. We've seen this head to tail one, okay, before. I'm going to show you why I like this parallelogram one too from time to time. But we'll talk about that later, okay. Hiking. So again, here I have a hiking problem. And so let's see how this works. It says, while hiking in the woods, Shelley walks 2 kilometers north, or 30 degrees west of north from her camp, and then walks 2 kilometers directly east. How far and at what quadrant bearing is Shelley from her camp? Okay, so let's talk about this. So first thing I like to do is I always like to draw it as the way it's being told. So I start here. And so that's 30 degrees west of north. So again, I have to do, let me give myself a little bit more room, guys. Okay. So I'm going to start it here. Here's my north. Okay, here's my starting point. And it's 30 degrees west of north. So here I am at north. West is this way, 30 degrees. And there's my angle. And I'm going to say she went 2 kilometers in that direction, so I'm going to say 2. Boom. And then she walks 2 kilometers directly east. Well, here I am this way, and I go directly east 2 kilometers this way. Boom. There's my 2 kilometers directly east. It wants to know how far and at what quadrant bearing is Shelley from her camp. So here's my camp where I left from, C, and I want to be able to find out this right here. It's asking for a resultant. That's what it's asking for, guys. So this is how I do this from here. It's asking for a resultant, right? Because I add this one plus this one. Add these two, I get that as an answer. So how do I do this? I set this up by my components. I'm going to call this one A. I'm going to call this one B. Okay, so when I draw out A all by itself, and I draw out A just like we did before, here I am, 30 degrees, here's A. If I draw out my other axis here, and now I want to find out my components. So A of X, A of Y. A of X equals magnitude of A, which in this case is 2, times cosine of what degree measure? Again, from the x-axis, from here to here. So 90 plus 30, 120 degrees. A sub y, what is that? Oh, that's going to be right to sine of 120 degrees. We already found that out. Great. The next one is I want to take B. I want to find out and draw itself differently. So again, I draw itself out here. B. It says due east. So here I am. Here I am. Due east, right? That's right on the x-axis. So if I draw out the other part of this here, right? B. It's right on the x-axis. So if I wanted bx, that's going to equal, again, this is 2. Magnitude of B is 2. Cosine of how many degrees? Well, if it's right on the x-axis, no degrees. By is equal to the same thing. 2, oops, not cosine. 2 times sine of 0 degrees. I go ahead and grab my handy candy calculator. I see that this right here is equal to a -1. And then this one will equal, when I put that in my calculator, square root of 3. And then when I go ahead and put 2 cosine of 0, hopefully you should see that, hey, what's the x component of this? X, y, us, the whole thing, 2. And then what's the y component? It's not going up any way. It's equal to 1. I mean 0, right? Yeah, 1. So now comes the easy part. They want to know the resultant, right? Because this is like vector A plus vector B is supposed to get my vector, let's call it C. So I want to do A plus B, which is equal to, the way I do it is I break it up into what is AX plus BX. -1 plus 2, that's 1. That's both these things, okay? AY plus BY, 0 plus square root of 3, square root of 3. Okay, so now what have I created? Now I have, this is the x component for my new resultant. This is the y component of my new resultant. Whoa, that's easy. But now this is where, again, you have to know another thing. How far west and to what bearing is Shelley from her camp? Oh, so let's draw this out. If I draw this out, here's my CX is 1. There's CX. My CY is square root of 3. It wants to know this when I add it up. That's a right angle. A squared plus B squared is C squared. So my magnitude of C, and this is something big that you got to write down, magnitude of my resultant is the square root of CX squared plus CY squared. And when I find that out, This is going to be silly for this example because you're going to go, ha, 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 ha. The magnitude of C for this example is equal to 2. Boom. All right. Last but not least is what angle is she at? What angle is she at? Okay. So how do I find an angle? Back to trig. Okay. Sorry, it's true. So how do I find my angle? I take inverse tangent. Opposite over adjacent. CY over CX. Plug that in my calculator. I find out it's 60 degrees. Woohoo! I'm done. Okay. And did you guys see what type of angle it's looking for, guys? Okay. Again, calculator work. I trust that you can put this in a calculator. Okay. But the hard part then is saying, okay, look, that's right here. There's my 60 degrees. But they want the quadrant bearing. Oh, quadrant bearing. That's that whole so many degrees west or east of north. They want this. So this here is north. I want this angle right here. Well, if I want 60s here, 30s there. So my final answer is, okay, she is now 30 degrees east of north at 2 kilometers away. Final answer. And you're going, oh my God, that was horrible. Trust me when I say this, guys. It is less horrible than other ways. Okay? Trust me. Let's do the last one together, and we'll call it a day. Actually, I'm going to let you do it because I'm already over the limit here, guys, okay? So I'm going to set it up for you, though. It says here, oop, I thought I got rid of this. I'm sorry, guys. We'll get rid of this here. Okay, so here we are, second example. It says, in an orienteering competition, that means you're walking around with a compass and a map. That's all you have is a compass and a map. Is what an orienteering competition. Miguel walks 80 degrees east to north for 150 feet, and then walks 200 feet due east. How far and at what quadrant bearing is Miguel from his starting point? Okay. So, here we go. First thing again, draw out the way that the guy went. So that's our first bet. So I start here. It's north. Here's north. And I don't want to draw an arrow because I don't want to confuse people, but there's north. And 80 degrees east of north. So here I am, 80 degrees east of north. So I'm going to draw out east here. 80 degrees east. So it's almost the end. And I get a different color. And there I am. I went how far? 150 feet this way. And then I walked 200 feet due east. So here I am. Ooh, that's not very good. 200 feet due east. And then they say, how far and at what quadrant bearing is Miguel from his starting position? So again, they want from starting position to here. And there's this itty bitty triangle that's formed. So again, I need to break up this into my separate parts. Okay? First part is how he went. So I'm going to call this one, again, north. Here I am, 80 degrees. Here I go this way. There's the east. And I'm going 150. So that's the setup for the first one. Okay? So you got to ask yourself, what degree measure is this here? That's 10. So what you need to find out, and we're going to call this one A. I want you to find AX, AY. Set it up for me. Okay? That's your first step. Next step is to do the same thing, but for the second part. So the B part. So here I am, B. walk 200 due east. So again, here's B. What's BX? What's BY? Set it up. Okay. And now I want to find my resultant. I'm going to call that C. So I want to set this up as find CX, find CY. And here's your hint. That's equal to AX plus BX. CY is AY plus BY. Gotta find your magnitude of C. So once you get all this, square root CX squared plus CY squared. And then find your angle and make sure it's the correct angle. Okay. So I'm going to pause the video. You got to pause the video. You got to pause me. And the answers will be up shortly. Okay. Pause me. Please. Please. I want you to try and pause me. Pause me. So following all the previous work, boom. Here's all the work. Here's the answers. Okay. All right. Notice down here. So here's the AX and AY. BX and BY. Add them up. AX plus BX gives you this. AY plus BY gives you this. Do this formula. You gotta know that formula. Gives you that. And when I take my inverse tangent of CY over CX, it tells me it's 4 degrees. Woohoo! Am I done? No. Remember, that's from the x-axis going up is only 4 degrees. I have to use this weird orientating thing. Okay? So that means that's 86 degrees east of north, just like you saw in the previous example. All right, guys. All right, I'm going to cut it off here. It's been long enough. I need you guys to watch this and pay attention. Need you to get this straight. Okay? See you next time.